Morning, everybody. Let me welcome you at the first workshop of this last day of the conference. And I will basically start with one thing. There is a grand finale of the conference that you can join at the end of the conference. I think it's 4:30, where you can win some nice prizes, like some boards, YubiKeys, and stuff like that. I think you can find a description either in the books or on whiteboards. And let me pass the word to Ondřej Holeček, SUSE QE developer, software engineer, SUSE software engineer who works on OpenQA, and that will be his workshop.
Okay, good morning in this unholy hour. I have for all. Since this is workshop, I imagine that you will be also participating in it. But of course, if we don't have, so that's fine. I'll just pass some sticks with there, and then we will find the virtual machines for working with OpenQA. So you don't need to install anything. And for the Excel.
It works for the VirtualBox or for the machines? It should be for VirtualBox.
Well, unfortunately not.
Okay, but I think whole system, because I don't have Linux here. So.
Well, we didn't even try to run it.
Okay.
Doesn't matter.
Okay, thank you.
For those who are trying to run it, there you'll find.
Is it possible to boot from the stick?
No, it's not. It's not. There is. Oh, there's one file, the OpenQA table, which contains the image and it contains the image and definition file for the virtual machines. If you want to run. And who will be somebody using this? You will or no?
I'll do that.
Yeah. Okay. So this is just instructions where to put it. You can, of course, put it into a different directory, but then you will need to edit the definition file for it. And for the rest of you, that's it. I've always it. Okay. I will cover only the first two parts. I will skip the installation and administration. That's I use these workshop slides for our internal training. So it's a little broader, but we don't need to do that today. So at first, probably we were on my presentation yesterday. So this is just only a little cleaner picture. How it's the architecture of OpenQA. So we have administration node, then we have web UI and API. This is Mojolicus framework. If you know Mojolicus, it's a paddle-based framework which looks like Rails. It tries to imitate the workflow that Rails or Rails system works. It provides the UI for the browser and of course the REST API for external applications and the worker. Then we have a standalone scheduler and WebSocket server, which is not displayed here, but it's a different process also. and database external. On the worker node, we have a worker which is a middleman between a test engine, which is OS Autoins, and web application. The dashed line from the OS Autoins to Web UI, it means that there are some situations or there are possibilities when the OS Autoins can talk and upload results and ask some stuff from directly from the Web UI without using the worker interface or middleman. And it's used mainly in for multi-machine tests when you are asking for the state of children, jobs, and so on. So, purpose is the same as I was looking on the presentation. Integration testing, acceptance testing, single and multi-machine testing. You control it when you write the tests as if you were control it the machine by yourself. So when you typical scenario when you are developing new tests, you just do all the installation by hand for one machine. It takes notes what you do, what keystrokes you press, where you click, and so on, and then just write it down in the test API. So this is how basically they look like. We have one main test loader. It's called main PM, and basically I don't know how much you are familiar with Perl. Yeah, you are. So the main PM is not actually executed; it's only required. So this all the variables or all the commands are not in any subroutine. It's in the main section. So when it's required, it just goes and evaluates all variables using our helpers, and then loads whatever test it's enabled. These variables, when it's accessed by getVar, it's the variables it gets from the scheduler. We'll see later. And then the test itself are executed. There is a mistake because there is a run subroutine. I don't know how I missed it, because they are executed. Every test has a run subroutine. It's called run, and the test executor executes this part of code. Yeah, this is there. The another thing is are needles. We'll show how they are created. Yeah, it's basically screenshots with some metadata where you write the tag. So you can have many different screenshots with the same tag. So when you are matching the screenshots in the test, you just put the tag name, and the test engine will try each and every screenshot with the same tag to match it. Our test API, it's some helpers. We try to use that the test API itself is distribution or OS agnostic. So in theory, you can test even Windows systems and using OpenQA on openSUSE. And for example, for OpenSUSE Tumbleweed, we actually have tests which test the dual booting. It doesn't do anything fancy with Windows, but at least it's start to boot it and check whether it's actually working after to ensure that when you install Tumbleweed on a dual boot machine, that it won't screw up your Windows installation. So this is proper to just clarify the naming, because I usually speak about tests and then somehow I switch to jobs and so on. The tests is only the code. This is like if you compare the process. Job is to test as process is to code. When you execute some binary, it becomes a process. So job is the test which is running, test is only the code. So that's when I will, when the scheduler will generate all things you will want to test. He actually generates jobs. He generates it from the test code. Yeah, just to be on the same page with the naming. Yeah, sense. Another concept is the variables. The variables divided in several categories. They actually are, you can choose whatever category you want and put everything in them. That's not like you have to put all the hardware related things to machines. You can put everything just to one, but we just choose to divide it, so it's more logical to have some variables which influence the creation of virtual machines and so on in the machines tables, and which influence the other test or the job flow in the test suites, and medium times if you influence the, for example, the installation methods and so on. Then the job groups. Initially, it all was done automatically, but we then changed it a little to when you can manually, so that it doesn't do every combination, but you can have job groups when you specify for which machine or defined from the tables run only the specific test case. So you don't have to always do the same complete to schedule every possible combination. Yeah, this was you just have that's like a job group. You define the machines like x86, 32-bit or RR. Then you have test cases, test suites, and then you just enable. The architectures are from the medium, and then you just enable different machines for different combination of data. Scheduler will generate the proper jobs. Yeah, probably I can show you how we use it in a real world. Interesting. So it will be a little more. I just hope that Wi-Fi will be working okay. Yeah,
You can use.
I can use that. Oh, okay.
Yeah, it's way faster to use the.
Yes. Where is my? Okay. Quiet connection deactivated.
I was told it should work, so.
Yeah, I don't know. It's network manager is complaining.
Haven't you tested it?
Network manager, right? Yeah, but I'm already. Yeah, I'm trying to log in. In the meantime, it's strange I can't open another tab here, but I will, when you boot the machine I gave you on the sticks, it will automatically start the web UI and Apache, which we use as a proxy for that, because our web UI is running on always on local host and some report. When when you open it, it's completely empty. You can, you will be initially logged out, but we support the various authentication methods, and for this one, the fake authentication is enabled. So when you click just login, you'll be automatically logged as a demo user. And in admin tables, admin section, there are the tables. They are empty here, because it's a brand new installation. But basically you can add all the variables you want. I will show you once I logged to the. Doesn't seem work very well, but anyway, this is how they look in recent versions. In the job groups where you have selected, you create a new job group. Then if you have defined machines and so on, that will allow you to create the connections. But yeah. Did you manage to start it? Oh, no. Yeah, okay. Yeah, I was hoping we will write some tests together, but this way I can only show you how we do it. For example, yeah, I will continue with the presentation there, but because I have some links. Okay. So this is the built machine tables you see. The backend, you don't need to specify. If you don't specify it, it will automatically be queued. But you can have the PowerPC S390 IPMI for hardware testing. The worker class, I will get to it. That's a good thing to distinguish when you have some specific configuration on some hardware, for some virtual machines or hardware. You can use worker class to limit some tests only to be run on this set of workers. You can visually use this to specify memory, networking, different networking, and so on. In a test suite, you see the same. Use the logical things you would expect to influence the job workflow. And media. So the assets tables are generated automatically from the when you schedule a new ISO or some new build you have. It will create because when you schedule it, you need to put some mandatory options, which are the architecture, the flavor, the version, and the distri. The distri is when you reorganize all the tests. We are writing in different directories. So when you have tests for Windows and that you test for some Linux stuff, you put them in different directories, and then you use distri to differentiate between them. And job groups. We create a new job groups, and it will show you the args from the medium, which is because you create a new job group, and then there is a button to associate the asset or the medium with this job group. You can add more mediums to one job group, but yeah, it's a little confusing because I know that when I am doing this at work, almost no one get it on the first time, so I understand, but that's once somebody gets used to it, it makes usually good sense. Okay. Slowly managing to log in. So these are the links when you can look for the test. all tests are on GitHub. I think this link is still correct, like for Fedoras.
Yes, that's
Yes,
the Fedora
okay.
test. Yeah.
So there are the Fedora tests, you can see. Yeah, you probably don't get this one because this is the internal one, but you can get needles for openSUSE and tests. So the tests, we actually share the test with SLES and openSUSE, so
The Fedora needles are in the Fedora repository, they're not separate.
yeah, we have different
Yeah.
layout for this. So we can take look in this. Yeah, it's logging.
What was the second command you do after you define the virtual machine? You do a verge define,
Yeah.
XML, and then
You can start it. First, I think start. But if you do you have web manager? Something? Yeah. So in web manager you can open it. Okay. This one. This is I'm not logged in yet. This is from the actual openSUSE. These like these updates and so on. These are the actual job groups. When you create a job group, it will create also them. It will create them in the overview. So that's the also purpose of the job groups, to organize them in a, so you can see what's in some good overview. Still not in. We are on the GitHub thing. It's really strange that the network is not working for me. This is it's not loads completely. So I will okay, here we are. So this is I will show you the main PM, which is the test loader for the openSUSE tests. It's quite long, but hopefully GitHub will show it in a moment. In the actual layout, you see the tests. We have the actual tests. We have a lib when you want to create some new library or some helpers for the tests. We put it in lib, and it's actually automatically appended to the parallel search path for the libraries or modules. The data thing is where you put some static data you need for tests. For example, when you want to download some data to parse on the testing machine, you put it in data, and then our test API functions, which helps to download some stuff to the testing machines. They are automatically gathered from the data architecture, data directory.
So I can say if anyone is like a little overwhelmed with all this, it is nice. We found when we start out, you don't need to know all of these things. It's quite easy to set up one or two tests, and all the combinatorial variables you can just go by trial and error until you get through it, and then you get 2 or 3 tests running, and a lot of this stuff is just what you need when you get bigger, and you kind of figure it out. It makes sense as you get more tests built, right? But you don't need to know it all to start out.
Yeah, that's true. I have too many Firefox windows opened now, so I'm getting lost here. That's not what I wanted. Oh.
So I've also got the machine running.
Yeah, perfect. So okay, I will just finish how to run the test, and then we can see how to write it up, and then start. But I need to find where is the
Just need to relocate to get some power.
yeah. Sure.
Otherwise,
Where is the presentation I had? So anyway, I will continue from this clone of it. So this is as Adam was talking about. You can run the jobs in two different ways. When you want to use all this distribution combinatorics from the tables, you run it in, as I call it, as ISO-centric approach. You just get a new ISO, a new image we will build, and with our API you just schedule. You pass it that I have basically said I have this new image and schedule all the jobs you can find for it. And then we have a job centric where you can create just one job, and you don't even need anything in those tables.
thanks.
So. Yeah. This is for the ISOs. You put it in the directory. It's partly OpenQA factory ISO. This directory is usually shared because we need some common, some shared storage when we use remote workers. So this basically is exported as NFS or whatever you want to use, as long as it's a regular file system and not some object storage. And then created the post request with the ISOs path as the mandatory variables, and it will basically create whatever test. It will return how many tests it actually created and IDs of the test. It's returned back in a JSON format. On the other hand, for the individual tests, you use jobs path for a post command, but it doesn't consult anything from the tables. It completely ignores the tables, so you need to specify all the variables yourself. There is one middle ground for that, and that is when you use the ISOs post command and specify the test variable with the test name you want to create. You want to schedule, and it will take all the things from the tables, so all the tables you have, but only schedule the one test you specified. And the reason we did this because with this approach, when you have a multi-machine test, you create only one, and you need. It's very hard to create multi-machine tests using this, because when you specify it in the variables, you just say that I want this test to be run with this test, with the name you have it in test suite. But internally, when the tests are created as a job, all these links to between these jobs are transformed to their job IDs. So when you nice. Okay, it happens. And so when you want to hack around and use this one for multi-machine tests, you will create one job. It will return the ID, and then you will create a new one, and you just need to add a special variable, which is underscore parallel underscore jobs or underscore run after jobs, and you put the ID of the previously created. So really hacky. So that's why there is the middle ground with the ISOs post when you specify only one test name. But it will also, if it detects that there is some dependent tests or parallel tests, it will run them also. So that's why there is basically 3 ways how to run it. But yeah, it's all in a parallel nature, right? And yeah, for the when the tests are already running, we have also numerous ways how to restart them, or as we call clone them. Also either using web UI, but you need to be logged in. You need to have at least operators authentication level to do that. The same applies when you want to run it from the command line. The client script actually there's no magic in it. The only thing is that the part, this one is the path of the REST command. The client only reads configuration, so it knows what host name is the OpenQA on. The API key is used for authentication, and all the REST API is API/version1/ the path. So it will prepend will create the complete REST query, and this is the method we use. You can use post, get, put, delete, whatever. Yes, in the REST fashion. There is the clone job helper, which can clone all the jobs. But what clone job can also do is, for example, when you have your own instance running and you want to clone jobs from different OpenQA instance, you can specify to clone jobs that you can from this URL, from this instance, from the OpenQA running on this URL, clone it to my OpenQA instance which is running on different URL, and it will actually ask the remote OpenQA installation what all variables you need, what assets you need, and so on, and it downloads it and pushes it to so you can clone from different OpenQA installations. Okay. So in this section, it was how to write a test. I started from the easiest way, and that's how to enable it. How to just when you have failing test, so you need to update the screenshots only. Yeah, this is again as I was talking again, reiterating just so we remember it. And yeah, this is the 3 things I will cover. The graphical mismatch. That's when, for example, new branding comes in and you need to change only screenshots. Workflow change, when you need to put some new commands in it. For example, you get new license or added license, so you need to add new commands. And completely new distribution. That's the hardest part, because for first 2 you usually don't need to mess with the main PM. Or when you are writing completely new tests, you need to write there. And the problem also is that we, as for openSUSE tests, have so much helpers and so many base classes for the tests that the way we actually write the openSUSE tests, if you want to try it from scratch, you will find that you are missing so much stuff. So yeah, that's little. Sometimes it's unnecessarily hard to write to begin the new test suite, but yeah, sometimes you have to. Before we can even determine what's wrong, we need to see where the problem is. So the job can be okay fail or soft failed. Oh yeah, the job is okay fail, and modules are the soft fail. Passed and failed. It's self-explanatory. Soft fails is when the during the test detected that we need to use some workarounds to get. We know that there is a bug, but we know how to work around it, and we can continue. So when we do this workaround things, we can mark it that basically we used workarounds. So it's like it passed, but yeah, it's not very okay. It is still in this slide. I still use the old colors, but this color is now more greenish than yellow now. But see, and you may also see these icons. There can be 3 of them, and it depends. This one is the importance of the test. So, for example, it will not abort the whole test, the whole job. But once it failed, even if everything else passed, the overall result will be failed. A little harsher is the fatal flag. If it fails, it aborts whole test and it doesn't even try to continue on it. And the milestone, this anchor icon, it's a thing that when this job module is passed, it will create a snapshot of the current state, and when the automatically, whether you define any other variables or not, it will always create snapshot. And the effect is that in the next time when some module fail, even if it's important or not, but if it failed, the test engine will automatically reload from the last good snapshot and try to continue from that one. So it tries sometimes to revert to some known working state and see whether it will work its way for the rest of the test. For the needles, when you select the failed test, you will then see all the needles. The green ones are passed, the red ones are failed. So I was saying the tags, the needle, all needle has their tags, and it's basically, this is the algorithm. It's matching very different screenshots with the same tag. It tries and it takes just one which fits. So part of the metadata is matching area. For example, when you generally don't want to match whole screen. For example, when the time is changing, you would need, it won't match any, and it won't match at all if you are comparing the whole screen. So we just specify the region we want to be matched, and that's part of the needles. I'll just quickly check how are we on the. Okay, oh, this is fine. Ah, okay, I'm finally logged in. So.
Just hope it didn't time out.
Yeah. I wanted to show how our tables look like. I may open this one and just stress test the Wi-Fi. Open it in the background. Okay. So we're here. So this is we are updating the needles. Here we have some fancy things like a needle editor, which looks really daunting, but you basically need to learn some basic workflow only for that. This is, you can see that there is the screens, the names are automatically added, generated there. Here are the tags. The screen isn't very readable, it seems, but you basically add the tags. You either have already some predefined. You can copy them usually from already existing needles or add yourself. Here is the workaround property, which will mark it as soft file if this needle matches. And this is the way you update. You just select the wrong screenshot. Here, this is the already existing screenshots, and the first one is the one which was captured in this job run. So that's the most up-to-date. You can then specify either new matching areas or copy matching areas from some other needle. So when I select this one, it means that I copy the matching area from this needle. And the same, when I select the tags from this needle, I just copy them from that, and I don't have to invent my own. And then you just save. OpenQA can be configured to automatically push these changes to a Git repo if you have needles in its own repository. For openSUSE, we use this functionality. So when you try to help and update some failing needles, save it, it automatically pushes it, so it's it's automatically deployed on the system. So it's quite easy. If I have, I don't have how the matching works is that you don't have to worry about the explicit location where you put the matching region, because
You had it on the previous slide, or a little bit back, where it was explaining matching yet.
Yeah, it is.
Right at the bottom.
Right. Yes. Yeah. So it started with when you expect to be, but if it's not there, it's just making like spiral motion and expanding search area, and when it's hitting the timeout, it tries just to whole screen and just try to find it somewhere there. So it's reusable. Like when the scripts, for example, when you are checking for some text data from the log and you are using screenshots for that, and you don't have to worry that sometimes it's at the end of the screen, sometimes it's on the top, and so. So, this is how to update needles. For test code, the workflow usually. With the filed module, with the filed needle, there is a test code viewer, which I show yesterday. And do I have? No. We didn't do anything. Yeah. Too bad. So you can use various tools to find where the problem is, either with needles or with the videos, or the auto install gets a log from the test engine if there is test code error. You just need to update its module. Maybe I have the GitHub somewhere, right? Do I have?
Sorry, Andrew, can you just give me a second? I have to go to a lunch talk, but we run OpenQA on Fedora. We'd love to have help. If anyone is inspired by this, you can get in touch with me anytime, and I'll walk you through helping with our OpenQA and any questions you have deploying it on Fedora, because we have it packaged for Fedora too. So I'm Adam Williamson. For anyone who doesn't know me, I'm around at the conference and I'm Googleable. Thanks.
Oh, I can show you the actual. I don't need to use GitHub, right? Alright. So let's see this. This is actually for update. have. Where did it go? Oh, So, this is how our loader looks like. Basically, this is some helpers we don't usually use your writer's own. This is for cleaning, it's still. And basically it starts always ask for various variables which if they are set or not. We have also some helpers that you can ask to. Yeah, I don't know if this yeah, this is just setting some other. You can check. You can get variables. You can set during this. You can modify or all this is part of this API. The documentation for test API is in the test engine code. It's plain old. Yeah, it's paddle based, so it's POD data, and you can export it to.
If you store the passwords in clear text, directly, do you somehow encrypt it before pushing to Git?
Not this. It's one for tests. These are visible in a GitHub too, but they are used only in our test machines, and we even have some very SSH private keys there in GitHub. But that's it for use for testing. I know that we will get to some statistics about it, but but that's never used anywhere. Yeah, and at the end it looks like this. Just load all the things you want. Important thing is that this code is executed before the virtual machine is running. So you don't have access to anything, you can't check anything regarding the tested system. Also don't use any sleeps here and so on, because it's then blocks many things. And for the actual tests, you can see, for example, for upgrade of the system. The zipper job is, if you know zipper, it's like apt get or it's for installing packages and so on. And it can do also a distribution upgrade, and zipper is using this. Now you see, it's parallel. This is the tricky line, the use base, the install base test. That means that we are not using the base test shipped with test engine itself, but we are using our own helper, which already provides some functions which may be used here. And then we use test API, and this is the main run. We have some precompiled regexes here from the parallel, and when this when states script run, it actually do is that it will type this command using the keyboard, like the VNCEO on the tested machine. But there is the other benefit that the script run checks when the script is finished. It will automatically append the redirection for the serial console with the exit code of the command. So when you are saving the screenshots, you are guaranteed that this command is finished. But you are not. The script run doesn't check whether it was successful or not. We then have assert script run, which kills the test if it fails. There's also that thing that the script run, even though it's part of the test API, it uses Linux specific things. So, for example, you can't use script run on Windows machine. You need to use a type string, which just type the string, or override it and create your own helpers. Since this is all object-oriented Perl in the most basic way. No, those. Yeah, Perl has some strange ways to do some object-oriented stuff. So you can override some functions and then inherit from them. And basically, the same. You can wait for the serial output. With it's just waits and collects from. At all after this command is finished, it sets the pointer, not the pointer, but the position. So when you open the folder, it seeks at the end of the file, which it's gathering the serial output, and between this run and this run. This run and see only what was appended to this file after end of this serial. So it doesn't match all the previous stuff. So you can be quite sure that anything happens between these two calls is the new stuff and not the old one. Yeah, and this is test flags. Here you can set all the whether it should abort the test suite or not. This is still we have it's not documented, but like best practice best practice things. You don't actually need to set fatal and important into one, because that's. Inherently, if you have a fatal test, it's also an important one. Also, many tests won't have these test flags at all, even though some important flags is set, it's because it's usually done in the base test, which we are inheriting from. So you see that when we are writing this call, it's just look at the stuff and do the stuff as you would expect when you are using the machine yourselves. So still, here we have some result partially loaded. Oh yeah. Or is it from yesterday? Yeah, this is how you check the results. The good thing is that when you have the waits, when you wait for a serial output, it will instead of the screenshots, it will print you the thing it's captured on the serial output. Yeah, that's the network problem once again. So test call update. Yeah, you just update usually the test itself. And from scratch, when you create the test from scratch, you need to create complete new test loader. So I was saying also when I was preparing this and when you are trying to write a test from the scratch, since we use so many helpers, let's say, yeah, even our test loader has so many helpers that when you get used to it, for example, when you start working on Fedora's test, and then they also used many helpers, and then you will want to try your completely new test. It's actually sometimes very misleading. You will need to learn the basics. You just you need to be aware that all of both Fedora guys and openSUSE guys, we are using so many helpers that you need to be watched for that. Yeah, this is the test structure. I already talked about it. Yeah, this is one of the things. because when I was showing our test loader, we just use load test everywhere because we have helper which adds this that you don't need to prefix it with a test with a module, which is probably bad thing because we should put it as an exported symbol into the auto test, but yeah, no one fixed that yet. So yeah, but at this in this slide it's correctly set. So this is again test loader. Again, reiterating, the machine is not running, so you can't check anything except different variables, and that's it. Test module. This is probably the one of the shortest. You don't need to use strict here because we enable it by default in our base test, and all the tests which inherit from it automatically have the strict and warning enabled. So we use something like modern Perl module, and then basically for the test API, the assert screen is to check the screenshot. This is the tag of the needle we want to check against. X11 start program, it's what it does. It starts the xtem in the, but it actually expects that you are in some graphical environment. Again, highly Linux specific. The same become root, and this is the only thing. From asset screen, a type screen is universal, so you can use it on even different OSs. The rest are very Linux specific. Yeah. Again, the only mandatory subrouting is the run, the test flags are all optional. Many returns also. You need to inherit from at least the base test. Base test is, I can show you. That's the beauty of openSUSE, that I can show you all the sources. So this is the test engine, and somewhere base test. Yeah, base test. This is the source for every test is based. It prints you can get these statistics even in tests if you want it, but it's not really needed. And it also defines some over some helpers to say this is here. We are untested, just untested. Yeah, this is good that we have hooks which you can run before the test, then when test is run. This is basically that in the test itself you put the run pre-hook subrouting, and it will run before test, then of course post run, and then we have fail hook. When it failed, you can run post fail hook. You all can put it in your test cases, test modules, and execute them all together. But what I wanted to show, that except the test API, there is also distribution thingy, which is full of that test API. Usually, sometimes for basic things, it will set let's say it will the test API has some low-level stuff like the type string, access screen, and then this X11 ensure installed and become root and so on. It checks if you have some custom distribution, which inherits from this distribution, and this is the where you would want to override. For example, when you are preparing for trying to test Windows, you will create a new like Windows distribution or Windows whatever, inherits from this one and overrides the helpers, and then you can use it even by test API, but you need to at first override it. And in tests, I didn't show you, but not working expected. Okay. In the loader, at the beginning of the loader, we have a helper. This one. So basically, in the lib directory of the test, I showed you do yours distribution. For example, like if you want Windows, you will do Windows there. And then in the loader you just set the distribution, and it will instruct the test API that basically all the overriding stuff you have to again will come into the effect. So this is required for some different OSs than Linuxes, and even there. Let's see. At our SUSE distribution, I don't even know what all likes we have here, but yeah, initialize some commands, I don't know. Yeah, this is another override, the installation, ensure installed, it checks whether the package is installed, even I think it only works in X11 and so on. You have many places where to put some helpers and overrides and so on.
I have a question about the test. If you have some tests, let's say you test if OpenOffice static, and you need to add some new tests. Let's say if when you open the help is some close button at the bottom. Yeah? So how do you identify the area for this new test? Because you don't have screenshots for that. How do you add it into the test? Yeah. Because there is only some save screen or check screen, but you don't have
the area. The save screen doesn't check anything. The save screen is the actual you want. You will write the test as that it will get to this situation, and then either you just wait for a few seconds and then save the screenshot. This saved screenshot will then appear in the results, and you just can create a new needle from this screenshot.
Okay, so this I can do from the web.
Do this from web page.
Okay, I understand.
Or you can create your own screen. You can do this by hand, like take a screenshot of the machine and add the JSON's metadata and put it there. So it's easier to just put a save screenshot call. It will save it and then convert it to the needle.
Okay. And I have a second question. You have prepared all these tests for some distribution. Everything is all fine, but now you need to test. Let's say some high contrast, so you change the colors and also change the font. You need to reroute everything, or you need only go to the website and change the needles through the...
Only through the website.
Okay.
But that's usual when, for example, new branding, let's say, usually the workflow is the same. You don't need to add any new commands, but you need to completely change the screenshots.
Okay.
And then again, you just reuse the same tag, so you don't need to touch anything at code. And it's also you can, but usually because the needle name is auto-generated, you don't overwrite the old one, so you can test the old version, the new version, and it will just work. Now, where was I? Yeah. I'm not checking it. Yep, test API. I have somewhere generated all the commands we have. Let me see if I can. Turn here. No. Yeah, this is generated from regular POD to HTML. This is all we have. They are in categories. So for output, the save screenshot, as we were talking about, so failure. For workarounds, you can manually, if you either can use the workaround tag on the flag on the screenshot itself, or when you use workaround like in the code, you just this. I don't know why it's in the video. Probably this is misplaced, but you can mark it anywhere as if you know it happened. Assert screen. They just they can be array or the name of or just the needle, and it will try to find one. Check screen is the same as assert screen, but without failing. The good thing about, for example, this one, the match stack, is that both of the assert screen and check screen, they return the tag of they return the needle like object which matched, and you don't need to save it. The last match is there is always we automatically save the last matched object, and you just can check what tag it was later, and don't need to use some special other variables. This is how you can click without actually specifying the coordinates. You can move mouse by coordinates also, but this is good that it will find the needle and also the matched area, and it will calculate the middle point of the find area and click on it. So when you want to just click OK, you just this one, or double click. Yeah, this is variables for still video handling, whether it's changing or whether it's not changing. This is for access to variables, so you can which influence the test workflow or the job workflow. Not very interesting, but intuitive. And then serial helpers. Just the white serial, which just expects the checks for the serial output of the machine, and the script run, assert script run, these are the helpers. The important thing is that when you as I said, the script run waits until the program ends. So when you don't want it, for example, that you need to check for some serial output yourself, you need to disable timeout or use type string instead of script run. So it gets a little to use it, to get used to all this API, but at least we have now a list of them. It wasn't such a case like 2 weeks ago.
There was no documentation?
Well, at first it was obsoleted a little because nobody bothers really to update the PODs, And it was all over the place because I actually spent a week working on collecting the documentation to be in the right order and do updates all these strings. And when you wanted to know which test API we offer, you just need to go to the code. And even some of our QA guys had no idea and use some. This is the thing that many people don't also know Perl as good. So when you are new to some projects, the first thing you do, you just copy and paste some existing test and adapt it, and that brings sometimes bad code style and so on. So yeah, the last week or two when I was preparing for all the presentations and so on, I basically was updating the documentation as well. Yeah, then you see we have some different, we can shut off the machine without, of course not all of them works for all backends. This usually works only for QEMU. Maybe it's also what I don't know. It's it's depending. If you will call it on a backend which doesn't support it, it will crash the test. So you need to be aware of that. Wait idle is currently being this this gradually we are stop using it because for QEMU it actually looks at how much the virtual CPU is utilized, and when it drops below some threshold it says okay, we are idle, but on the other backend it just sleep, so it stops the execution of the test for days, I think 19 seconds by default. I don't know why 19 per se, but that's in the code. So that's why we are dropping this and use the waiting for the serial line. Yeah, this is the things to upload the logs and to get the data you have if you have something that you really need something for the test. Uploading logs, uploading assets. Keyboard support, send key for individual keys. There's a mapping which we use for it. This is nice hack or helper when you, for example, need when you have a list of menu, for example, in a group, and you want to select only the third and fourth, and you don't want to put the send key in a for cycle. And sometimes it can even change the positions. For example, when we have a rollback for BTRFS, it's always different. So we just have a screenshot or a needle of the selected correct entry with the selected proper name, and we just said that hit down until you match the needle, and it will automatically iterate and try to push down and down and down until it matches. So it's sometimes useful. Yeah, it's like type string, type password, the same, but password is then hidden from the log. So yeah, you can use it to it's mouse support. You can move it. We have a mouse height helper. Mouse height is actually quite important to use because when you have a mouse cursor somewhere and you have it in a needle, it many times it can happen that sometimes the mouse cursor is hidden, sometimes not, and even the small cursor can make the needle to be failed. So we use it quite often. It just the only thing it does, it just moves it to some offset out of the screen, and just so it will not clutter not be in the needles. Yeah, the multi consoles. This is stuff which basically is it's again Linux only, but you can override it. But the idea is that you don't need when you the distribution test, the distribution part can because this part is not available from test API, at least the art console is not available from test API itself. It's only from distribution. That's mainly that the test, the writer of the test doesn't mess up with the system configuration of this testing system, and basically you can add some hooks for it. So when we have a root console, it knows that it's always on TTI2, so it always when you call then select console and root console, and it will automatically push control alt F2. And during the add control, when you are adding the console, it automatically locks you in as a root. So now you don't need to these like become root helpers. You just I need a root console and it will switch to it in the text mode. I need a graphical console and it will switch to if there is to the X7. And user console it's the alt F4 and it's user is logged in. So you don't need to like watch whether there is a login prompt and do I need to log in or it's already logged in. Yeah, and it's audio support. Just this is the last one. You can collect the audio. Yeah, as you saw yesterday, probably we can just you can play the audio in the web UI just to show how it sounds, but the OpenQA itself, it's just comparing the screenshots, even for the audio. Yeah. So if you want it, it's this is from everything generated from the test API PM. So, and we code it's classical plain on data. Each function has this above it and with what's happening there. Okay. I will see. Just API. Yeah. This is probably what you want also. The important thing is that by default, when you don't set when the test job is running and you don't set the results explicitly, and it will pass. It will regard it as a failed, or it will like. I think it will be state an unknown state, but the overall state will be failed. So you need to explicitly say that the result is okay to be actually okay, but you don't need to do it for failed. And of course, we use nowadays we just die, like not literally, but in the test because when you can add a reason why the test died, and it will show in the web UI because of this the test died. Yeah, recording failures. Yes, yeah, you already were about it. Debugging of the test. There are the various logs and files uploaded which the test produced. So there is it depends whether you are debugging the test suite itself or whether you are debugging the SUT or what happened. So for the debugging test, there is the important auto-inst log, the output of the test engine, where you see what needles was matching, what was typed into, and it's quite chatty, so you can usually find what's wrong. For debugging the actual problem with the tested system, we have these helper variables, and this will force because when the test is finished, and all the tests are all the data is uploaded, the image is deleted. When you specify the keep AGV as a variable, it will preserve it, and you can then copy it outside and do whatever you want. Make snapshots. This basically overrides the milestone flag, and it added to everything. So after each successful test module, it will create a snapshot. Then you can use skip2 variable, which will, when you restart the job, for example using the clone job helper, it will start the test from the milestone you specified. So that can be used either for debugging of the actual SUT, or when you are developing the test. So you don't need to again do the installation step and so on. So you just concentrate on the one module you are interested in. There is one drawback though, and that's for example these consoles. When you are using the console tests, the consoles are set up during the first module when the test is started. When you skip to it, it skips over the setup of the consoles. So when you then try to select root console, and you skipped over the initial phase, it will report that you either don't know the console, or that you will not be logged in and so on. So one needs to be careful not to skip over the initialization. Usually it's good for when you are testing the X stuff, because that's usually in the correct state. So. Yeah, this is I'm almost at the end, even with time. For dependencies, start after test, you set it as you do it as a variable, then you use the set test name, and it will create the chain dependency, which means that the one test will be run at the first, and the second test will be scheduled only after the first one is successfully finished. Parallel test that's the scheduler will ensure that all of these jobs will be run together. And thing to remember is that scheduler checks the state of the mass of the parent task or the parent job, and you need to write the test in that way that it will wait until the children will finish. Because when the parent job stops or finishes, either successfully or not, the children jobs are running, the scheduler will stop the children jobs. Just it will kill all of them. So we have as I was showing you the test API, we also have MMIP AI, which is exactly for multi-machines. Is it opened or not? No. Okay. And here we have, you see, this is what the API exports. So you can ask what the state in what state are the children, and from the children from child you can ask about parents, and even you have the call to wait for children. It will just wait, and but you need to be aware that the parent job needs to be running again, and for that we also because it uses the logs, and the logs we have in the log API, and it created, you have mutex create, mutex log, mutex unlog, and here is the exported into logs. So all these mutexes are named, so you just pass the name of the mutex you create, and then you can ask for it. And the important thing is that they are all these are always related to the job groups they are running. So when you, for example, run reuse the same names in different tests, they don't interfere with things. So you can safely use whatever name and reuse it. It's actually yeah, this is the it still can be updated, but so far for our test, this is what's good enough for us. The job asset, that's, as I said, difference between logs and assets is that assets are stored and can be reused in different tests. There is the difference between store HDD and publish HDD, and we have store asset and publish. Yeah, there's the API call upload asset, and you can specify whether you want it to be private or public. And the difference is that the private assets are the job ID is prepend with as a prefix for the asset. So idea is that the asset is only reused in the job group, and it's not reused outside of outside. So to guarantee that you don't overwrite it in some other test, if you use a public, it will you pass the name of the asset, and each test when you run it and use the same name, it will overwrite it. So that you need to be aware of. These variables are the store HDD and publish HDD. You use it as a test variables, and it will trigger the upload of the image, the machine, which finished. And then of course you have the API for upload assets for individual files. These variables are for the images. So that's a nice idea or nice thing. For example, when you test something and publish it, you can somebody else from even different tool can download it. I think we use it in a Jenkins workflow too. That when we install it to some state, publish the asset, the HDD asset, and then Jenkins is called on this ISO or ISO the image. So it do its tests, and so you can actually plug the OpenQA nicely in the infrastructure. Yeah, that's all from my side basically. Yeah. So.
I ask you, does OpenQA runs on CentOS or Gradle?
There are no packages, but they managed to package it for Fedora. So I know it's different, but it's not like SUSE specific. So you can no packages for it, but I see no reason why it shouldn't.
Or we can use the Docker?
Yeah, there is a Docker image for that. Yeah.
And you don't have CPAN module?
No, we will already yelled at some. Adam already yelled at us about for that, or someone, I think. We don't get nothing. We actually do sometimes some nasty stuff in Perl there, and yeah. So far, no one was complaining. So. And what I want to, yeah, but it's all in a build. For build service, open build service. We all currently build it only for SUSE distributions, but we can enable if there is interest for, I think CentOS support is there too, but yeah, so far we weren't approached for this. And Fedora guys just do it themselves. Any more question?
I haven't found this documentation online yet.
Which documentation?
Yes, you were showing us.
The test API? Yeah, it's actually you need to generate it yourself.
Okay.
Well, the plan is I didn't have time to finish it, but plan is that this documentation will be automatically generated and then published in the OpenQA repository. Because this is the test engine where this test API is this one, it's always auto-ins, but all the documentations about how to write tests, how to work with it is in OpenQA. So eventually, in the upcoming few days or a week or two, I expect to have some automatic uploading from auto-ins to OpenQA. And then there is also a certain documentation repo where these presentations are. There will be also my yesterday's talk, I will upload it there, and this one we are watching now is also there to see. And I think there's also some talk from other guys of OpenQA team, so you can see whatever. Basically all presentation we gave is there.
Yeah.
Okay. Yes.
So you're out of time.
Yeah.
Thank you for the workshop.
Yeah. Thanks.
Asi je fleška, kde?
Nemá to... Dva vlastně na tím celý. Pokud by se mi to nepodařilo, že bych ho trochu...
No, na ty flešce...
Aha, já jsem přišel pozdě.
Aha, jasně, takhle tam je tam virtuální stroj.
Aha, a to můžu nechat?
Jasně.
Poprosil bych slajdy.
Yes. You can keep it. Oh, you don't want it?
Thank you.
It's a git.
I think flashcards are one of the things you can always have.
Yeah. Tak ty slidy jsou v tom, já nevím, jestli to tam chcete nějak dát, nebo ne. Jsou i na webu. Mám někde i to, ono se to dá nějak přegenerovat, jako sprint, ale moc mi to nefungovalo.
Tak nevím, tak už tak možná...
Protože oni jsou na webu, a já můžu poslat tam třeba link, na to potom přidat dále.
Nebo vytvořit na té flashce teda soubor s tím linkem třeba.
Jasně.
To když tak najdou.
Dobře.
To by možná mohlo stačit.
Dobře. Akorát, že jak jsem mám otočený, já mám právě tohle nastavený jako pravou,
Jo.
jsem si to blbě dal, tak kde to máme. No. Čekal jsem, že to bude trošku jiný ten workshop. Ale no, to byl jako... Kde je ten výklad? Ale ta síť je divná, že mi to...
No, já jsem taky se snažil se něco udělat, ale vůbec
no, to bude možná.
už je asi prostě přetížený nějaký.
Jako ta Wi-Fi to rozumím, ale že mi nefunguje
Jo,
to,
tohle, aha.
že mi